So now we have seen how to create tensors, how to do operations with tensors, like adding them together, multiplying them, subtracting tensors. We've seen what the role of broadcasting is in this case. What we're looking at now is how to make selections out of your tensor. So to subselect a set of numbers from your tensor and not necessarily look at all the numbers at the same time. So to do this, we're going to look at the simple two-dimensional tensor, because then we understand how it works, but you can do this in higher dimensions as well. Oh, and I'm going to reshape this to be a 5 by 5 matrix. So if you look at X, basically you have these numbers 1 up till 25, so I have rows, I have 5 rows here, these rows, and I have 5 columns like that. So a number of ways in which I can select numbers here. So a simple way is to simply look at the first element, so that means the first row, which has index 0, the first column, which has index 0. So if I evaluate this, that will give me the number 1, which is the number in the top left corner. So if I take here the second row and its first element, it's going to be 6. So I can specify basically the coordinates, and then it will give me the number that is in that coordinate. So this is the second row and the 5th column. One thing to remember is you can also use minus. So basically it means you're starting counting at the end. So that basically means -1 here is the last row, and then this is the last column. So that's why I get the 25. I take the 1 up to last row, and then the last column, that's going to be the number 20. Yeah, so you can pick single elements out of your array using this type of indexing. Oops. You can also use the colon to basically say that you want everything out of that dimension. So if I consider the first column, so that's the 0 here, and I want all the rows, what I'm going to get is the first row of my matrix, which is 1, 6, 11, 16, and 21. Or I can specify here that I want the second row and then everything out of my columns. So then I get 6, 7, up till 10. You can make it a bit more subtle in the sense that you can also say start with the second row, go all the way up to the 5th row, but don't include the 5th row. And then let's say I want to do this for the second column. And the result that I'm getting then is 7, 12, and 17. If I don't specify an endpoint, it goes all the way up till the end. Then it goes all the way up till 22. So I can also say here that let's take the 3rd row and then show everything up till the 3rd column. So then I get 11, 12, and 13. And I can mix and match. So I can say go from index 2 to 4, and then here I do the same. Oops, I also go from 2 to 4. And then I get this submatrix with the numbers 13, 14, 18, and 19. So here I take steps 1, because I didn't specify a step up till now, but I can actually do that. So I can say go from 0 to 4 with steps of 2, and then give me everything that's in that column. Yeah, so then it chooses the first row, it skips the second one, it gives me again the 3rd row, and then it stops because I run over the index of 4, because it doesn't include 4. If I don't specify the 4 here, and I evaluate this, then of course I get an additional row. So I get 3 rows, basically alternating. So the first, not the second, the 3rd, not the 4th, and then the 5th. Another thing I can do is basically reverse the order. So again, if I look at x, so we look at the first row, and basically I want everything out of that first row. So it gives me the numbers 1 to 5. But then I can, as an increment, I can specify -1. And I can run that, and then I get 5, 4, all the way up to 1. So if I would fully specify this, I would say start at the last column, go to the first one, and that gives me the same result, except that this one is not included. Yeah, because it goes all the way up to the first one, but not including the first one. And the -1 makes sure that I'm reversing the order. So this is how indexing works. Now the fancy indexing does the following. So I can specify a mask saying, for instance, I'm interested in the values of x that are bigger than 20, and then I can look at x and apply the mask, and I get the numbers 21 all the way up till 25. I actually don't need to define the variable mask. I can also do this directly, so I can look at x and then specify that I'm interested in, let's say, x bigger than 10, and I can combine booleans, so I can say and I also want x to be smaller than 21. Yeah, so basically here I have my mask, but I haven't explicitly defined it as a variable mask. And now that gives me the numbers 11, which is the first number which is bigger than 10, all the way up till 20. 21 is not included because it's a strict sign if I make this. Oh, sorry, that should be the other way around. So now 21 is also included because it's less than or equal to. Yeah, so we can apply this, for instance, in a figure. So I can say that I'm interested in the x variables from 0 all the way up till 2 times pi, and let's say I'm going to take steps of 0.01. Then y is going to be equal to the numpy function, the sinus of x, and define a mask. Y is bigger than 0. Then I can plot x and y. And let's say the color is going to be red. Then I can plot x with the mask and y with the mask applied. And then the color is going to be green. Oh, I made a mistake here. Oh yeah, sorry. This should say mask is equal to. And basically what you see now is that the red part is basically the part where y is negative. And here we have the part where y is positive, so it's between dollar signs because I'm using LaTeX. And then I can ask for the legend as well. Yeah, so basically what happens is it first plots this thing in red. So basically it plots the whole curve in red. But then on top of that, whenever y is positive, I'm plotting this curve here with the color green. So here we have the green curve, which then corresponds to the values where y is positive, and the red part is only the values where y is negative, which is indeed exactly what labels are saying. Yeah, but of course I'm plotting here the whole x and the whole y, not just the negative values of y. But because I'm plotting one on top of the other one, it comes out correctly in the sense that the green line corresponds to positive values of y and the red line corresponds to negative values of y.